Welcome to the video Q&As for Managerial Economics, in particular Chapter 3. And the first Q&A from Chapter 3 takes a look at an issue with iTunes and their changing in their pricing. So in the first week after Apple's iTunes raised its price on its most popular songs from 99 cents to $1.29, the quantity demanded of Akon's Beautiful fell approximately 9.4% to 52,760 units from the 57,941 units sold in the previous week. What is the arc elasticity of demand for Beautiful based upon the average price and quantity? So here's our data that's important to us. We have the initial price. So P1 is equal to 99 cents. P2 is equal to $1.29. The original quantity of that song Beautiful by Akon was 59,941. And after the price was changed, the quantity fell to 52,760. So to get the change in the price, what we do is we take P2 and subtract P1. So $1.29 minus 99 cents gives us a change in price of 30. The average of the prices, so we just take $1.29 plus 99 cents and divide by 2. So $1.29 plus 99 cents divided by 2 gives us an average price of the two prices that we're looking at as $1.14. So we have the change in the price, and now we have the average price. We do the same thing for quantity. So the change in the quantity is going to be equal to Q2, 52,760, minus Q1, which is 57,941. This gives us a change in Q of a decrease of 5,181. We want to take a look at the average Q, which is 57,941 plus 52,760 divided by 2, and that gives us 55,350.5. Apologies for the delay there. Had a little bit of noise in the background that I had to take care of. So we have those calculations of the change in P, the average of price, the change in quantity, and the average of quantity. So with those pieces of information, we can move forward in calculating the arc elasticity. So the equation we're going to use is 3.2 from the textbook. And that tells us that the arc elasticity, which we will refer to as epsilon, is the change in Q divided by the average of Q, and that is over the change in P divided by the average of P. So if we put that information in there, we have a change in Q of negative 5,181. We divide that by the average of Q, which we had as 55,350.5. And in the denominator, we have the change in P, which is equal to 30 cents, and the average of P, which is $1.14, which approximately gives us negative 0.094 divided by 26,263, and that gives us an arc elasticity of negative 0.36 for Akon's Beautiful. Q&A 2. 3.2. Use calculus to show the elasticity of demand is a constant of epsilon at all prices if the demand functions is exponential, i.e. that Q is equal to A times P to the epsilon power. Given that the estimated demand function for the broadband service is Q equals 16P to the negative 296, what is the constant elasticity of demand? So remember, we're taking the change in Q over the change in P. So we have the derivative of quantity with respect to price, and we multiply that by price over quantity. So when we take the derivative of the original demand function, so we have APE, we're taking the derivative of Q with respect to P. We're going to be taking the derivative of this, And remember, when we take the derivative, we're multiplying by this exponential part in the front and then subtracting 1 off of that. So when we do that, we get epsilon AP to the epsilon minus 1 power. So we have epsilon A and P to the epsilon minus 1 power. And then we're multiplying that by P over Q. Well, if you remember, if we take a look at this, we know what Q is equal to. Q is equal to A times P to the epsilon power. So we can place that in its place. So we will get epsilon AP to the epsilon minus 1 power, and we'll multiply that by P over AP to the epsilon power. So what we're doing here is, if we multiply this through, we will, multiplying this P through, we will get back to AP to the epsilon power. So if we do that, we end up with epsilon AP to the epsilon power over AP to the epsilon power. This part here and this part here will cancel out, and we will end up with epsilon. So for that function, we will get that there's a constant price elasticity of demand for that exponential function. Moving on to QandA 3.3, suppose that the estimated demand function for avocados is given by Q is equal to 120 minus 40p plus 0.01y. The manager of a trucking company that specializes in avocado transport wishes to use this estimated demand curve to predict the quantity of avocados demanded at a price of $2.70 and an income level of $6,000. What is the predicted quantity? If the actual quantity turns out to be 76 million pounds, what is the residual, and why would the predicted quantity differ from the actual quantity? So here we have our demand function, and we have the information here. We want to predict what Q is given the fact that the price of avocados is equal to $2.70 and income is equal to $6,000. So we're going to place $2.70 into P, and we're going to put $6,000 in with Y. All right, and in doing that, we end up with a quantity is equal to 72. So here we have 120 minus 40 times the price that we were given, 270, and that we add in 0.01 times Y, which is the 6,000 from here. We get 120 minus 108 plus 60. That gives us a quantity of 72. So this demand function, the predicted sales of avocados when the price is $270 and an income is equal to $6,000 would be 72 million avocados. The residual is going to be 4 million, because remember what the question stated was that the actual amount sold was 76 million. So our model predicted that 72 million would be sold. So our residual is 4 million. So we were off. This model here, this demand function, was off by 4 million. And the final part of that question was, why would this be incorrect? Well, remember, this is a demand function. It is modeling quantity based on price and income only. There could be other factors that are important to determining what Q is going to be. For example, you might want to include temperature. All right, some people, if you think some people avocados think of that as more of a warm weather type of product, that people have a tendency to eat more avocados in the summertime than they do in the wintertime. It might be considered a seasonal variation because of that. So realize that this demand equation will not perfectly predict at the actual outcome. There will be a residual, there will be some level of error. And that error is due to the fact that there might be additional explanatory variables outside of price and income that help to predict Q that weren't included in the demand function.